The second part of the course will focus more on how to get current code to adhere to solid principles, instead of how to build code from scratch with these principles like we saw in part 1. For the single responsibility principle, we're going to take a look at this class. It clearly has multiple responsibilities because it has multiple extensions and none of them particularly related to each other. So one technique for refactoring multiple responsibilities out of a class is to use delegation. We don't mean the iOS term of delegation this time, but instead we mean one class having smaller classes within it that do things that that big class used to do. And slowly splitting responsibilities into smaller classes is entirely what refactoring is about. We're going to move slowly in this case so that we are confident that we don't break anything. So first, we'll take a look at this extension, which is UI View Controller Animated Transitioning. And we'll pick this one first because it doesn't have that much to do with the actual view controller itself. First, we will make it its own class and we'll fix any compilation errors that happened there. And then we'll link that back into the view controller itself. The UI navigation controller delegate can also be moved out. Now this isn't a big extension, but it is another responsibility that we could place elsewhere. Like many of these things, it's up to you to decide whether you feel like moving it is useful or not. With this one, we need to be a bit more forward thinking because it's a little harder to refactor, but we can do it. So the first thing to think about is that this self-check will no longer work if we move this out of this view controller's responsibility. So instead, we make it an instance check instead. The next step is a closure, and we'll use this to pass information from this soon-to-be separate delegate to the view controller and vice versa. And that will actually construct this show animal transition for us. Now we have to link it up. And now we have a much smaller view controller, where now we only have 2 extensions on it, rather than the 4 that we previously had. And actually, it hasn't changed the code all that much. We've had to add a few extra lines here and there, but now we have much more separable code. Another way to violate the open-close principles has got some pretty familiar solutions that we've seen before. Here we have a pretend coffee app. Let's say this controls a robot that you've trained to make coffee for you every time you press a button on your desk. This app creates a filter coffee maker, fills it with the type of beans you like, and then brews it. Now you've got some more budget in your office this year, and you can afford to buy a new, fancier bean-to-cup maker. The app has to update now to tell the robot to do the right thing with the new machine, because obviously it functions differently. So let's update the app code. Below you can see the bean-to-cup machine class, and it's fairly similar but not quite the same. So we change our coffee maker. We're going to have to change this functionality and then this functionality. So we've had to change all 3 lines of this app class just to swap in a new coffee maker. This means our app is not extensible, and instead we've had to modify it in order to get a change in behavior from something else. This is annoying, and you didn't really like the coffee from that machine, so you're going to replace it with an espresso maker. So this time, let's try making the system extensible instead of having to modify it. So when I said earlier that this has some pretty familiar solutions, I was actually talking about dependency inversion and list cost substitution. The solid principles are very tightly interlinked, and you'll often find that they overlap. And this is one of those cases, in that to fix one of the problems, we actually use the other 2 solutions instead. So talking about dependency inversion, we're going to make a generic coffee maker protocol. And ensuring that protocol conforms to list cost substitution means that we can swap one version of the coffee maker for another one without much difficulty or change in this class. So let's go ahead and make a common protocol called coffee maker. And we'll give it 2 functions. So we can make our classes implement this protocol, and you'll see that the protocol is slightly different, but still workable. And in fact, we can get rid of these other methods. Same with the bean to cup machine. And now all we do is make this forced to the protocol, which means that we don't accidentally use any specialized behavior in one of the implementations. And we just change this. So now our coffee app could take multiple different coffee makers, providing they have the same API. So let's make the espresso machine implement this interface. And now all we have to do is go back to our coffee app and swap this. And now our coffee app has been extendable because all we've had to do is change one reference. You'll notice that we have some duplicate code around grinding the beans. That's probably okay for now. My go-to rule is only refactor when you've duplicated for the 3rd time. But you could think about how you would represent this using protocol extensions, perhaps, with interface segregation. So strictly speaking, we have still had to modify the coffee app class, and we could take the dependency inversion further and make this a dependency which we inject in, and that would make then this coffee app class completely extensible with relation to how the coffee is made. So this is obviously a simple example, and in real life you wouldn't make this change for this code. In real life, you won't often have to swap out large pieces of code like this. Here we refactored some old code. If you find you or your team having to do a change like this multiple times on the same piece of code, you'd consider this type of refactoring. If the code changes rarely, or indeed never, then you don't need to do this kind of refactoring because your class doesn't need to be extensible if you're never going to extend it. If you're unsure of how often the code changes, there are tools online which can help you find these hotspots of code. You can try running these tools on your code and see if any of your hotspots are extensible, and if they aren't, then those are the places that you initially want to consider making extensible.